All right. And then we have one last session in this frame. We've got Kuldeep Pisda. Kuldeep is a full stack developer at Goldcast. Kuldeep is going to be talking about how we monitor and secure your infrastructure and also your first steps towards infrastructure as code. So I'm really excited about this. So Kuldeep, over to you. Thank you.
Yeah, thank you. Thanks. So yes, I would just like to extend what Shaurya did about breaking up monolithics in microservices. So I will start with a quote about theory of constant. So it says any improvements made anywhere besides the bottleneck are an illusion. Astonishing but true. Any improvements made after the bottleneck is useless because it will always remain sharp, waiting for work from the bottleneck, and any improvements made before the bottleneck merely results in more inventory piling up at the bottleneck. So why did I bring up this quote? Is mostly because in monitoring we try to do that, right? In monitoring we try to find the bottlenecks and we try to remove those bottlenecks and improve our infrastructure and optimize our infrastructure to serve our the customers, the consumers in a better way, in a faster way, in however way we can serve them better. So yeah, hi, I'm Kuldeep. I'm a backend come SRE at Goldcast, and I will be sharing about how what do we mean by monitoring in terms of APIs? How can we quickly secure our infrastructure if we want to, and then also a bit about infrastructure as a code and how can we move ahead for that thing. So yes, we all know that, right? The word monitoring is something that is that is self defining in itself. Like basically, we want to monitor something. But here we are at APIs conference, and we are talking about API. We were talking mostly about APIs, infrastructure, servers, and all of those things. So what do I mean by monitoring? And yeah, we'll be looking at what do I mean by monitoring, why do we need monitoring and how can we set up those monitorings, and yeah, I will go ahead with it. So yeah, what is monitoring, right? So we monitor anything, but in terms of APIs there are several key matrices that we would want to monitor, and notably the few common ones are the Apidays score, the throughput, the error rates. I will go. So I will explain all the points one by one. So, for example, Apidays score, it is actually a score by which we assess how our API response time is actually performing. For example, we define a threshold that okay, all our APIs must respond before 100 milliseconds to most of the API calls. And with there is a formula for calculating the average score, and with that formula, we try to find whether around 90th percentile of our users are actually getting served in that threshold or not. If they are not getting served in that threshold, then we need to do something about it. So yes, the first thing that we would want to monitor in terms of APIs would be the Apidays score, because ultimately, if we are responding late, we just consider an example, that you're standing in a shop. You have paid nowadays UPS are everything, right? So you paid the money to the the merchant, and you have a flight back to catch, and the status in your mobile application and or in the mobile application of the merchant is not yet reflected, and that person is saying you have not paid the money, you are doing fraud and all, right? So that will be a big issue, right? So that is something that we don't want to do. That's why this Apidex is something that we must consider ourselves. That we must monitor whether the Apidex score is below some threshold that we will have to define, obviously, and all. The second thing is throughput. Throughput is the number of requests that we are getting in some given amount of time, maybe in a minute or maybe in a second. And then we want to see whether our infrastructure is capable of handling those throughput or not. If it is not, then we need to do something about it. Maybe we want to scale up or scale out our servers and do some arrangement so that we can accommodate those extra traffic and all. The third is the error rates, right? So Apdex score and throughput is all great, but unless and until we know how many users are getting left out, we know who are happy with us, but we don't know who are not happy with us, right? And that is also a key metrics for learning a successful business, not only in terms of APIs and all, but rather in terms of business as well. So yeah, putting a threshold on error rates can is also helpful. Often we know, that this is the normal range of errors that we get. What do I mean by errors? Maybe some server, maybe some 5xx errors, some internal server errors, or it can even be about the client side errors, or specifically about 4xx response codes that we will be returning via the APIs. So a normal rate is something that is acceptable, but if let's say 5 to 10% of users are getting those errors, then it is a alarming thing, right? We need to do something about it. So yes, it is something that we should definitely monitor. The fourth thing is transaction time analysis on operation basis. So what do I mean by this is, for example, we made an API call, and the API responded in a given amount of time, and we need to analyze based on that, in that specific transaction time, what was the time that a specific segment took. Maybe a backend code might be one segment of it, the external EPS call can be one another segment of it. Likewise, the database operations can be another segment of it, and likewise, request queuing is also that can be another segment on it, right? So based on those segments, if we see that our transaction time has increased dramatically, and we see the data, usually the database responds within 15 milliseconds, but for some reason, it is taking, let's say, 500 milliseconds, right? Then it is alarming, and we can anytime go back to our database and see what are the queries that are causing it, what are the things that we should optimize on our database level. Should we put some indexes on some of the tables? Should we remove some of the indexes from some of the tables, or should we just refactor the database, and it will do the work? Or maybe if there is a request queuing, then we just need to add more servers on our load balancer, and it will just solve the issue and all. So yeah, this transaction time analysis based on the operations, based on this segment, is always helpful in a predetermination of what the problem might be, and that is something that is always helpful when we're delivering something to the customers. The third thing would be set up anomaly detection, right? So anomaly is something that we cannot detect usually. We can detect, but we cannot detect automatic. We cannot just randomly look at the data and say, okay, that this is something that is not working fine, right? But the tool that we might be using, maybe Prometheus, maybe New Relic, or any such tools, maybe Datadog, they know, they are aware about all those data that they have for us, and basically what they can do is they can apply some machine learning algorithms, and they can just put us a push put put a alert on Slack or something, that this is something that is behaving anomalous, this is specific endpoint takes this amount of time, but for some reason for the past 5 minutes it is taking longer than this. Then yeah, we can look for that service, and we can check if we had any new deployments on the service, and then we can fix it up, right? Which is super helpful anyway. So and the last thing will be what do you do about this data? Like, these are just some charts and all those things. Unless and until we put some proper alerting mechanism on especially on the key resources, it is not going to help, right? So for example, if some service goes down, we want to fix it, and in order to fix it, we must know that it has occurred. So maybe we want to integrate some of those software that will help us with them. Maybe it can be Obscene, it can be PagerDuty, or it can be any such service that that you would want to integrate with in your infrastructure and on, right? So when we talk about monitoring in APIs and infrastructure, I mainly see this point as the key points on which we should definitely put monitoring and alerts. Likewise, why should we monitor, right? As I said earlier, to optimize, to improve the infrastructure, to optimize the resources, to optimize the costs as well. We cannot have we cannot have 50% of our revenue going into the infrastructure, in maintaining the infrastructure. If we can optimize it, yeah, why not? It will eventually help us in increasing our revenue, right? To find the bottlenecks which might choke the infrastructure. Sometimes it is not. Sometimes it is not the. Sometimes it is that there a few key resources that are very very crucial for the service, crucial for the infrastructure. But and those are also the bottlenecks of the service. So we what we do is we often invest time in optimizing things that we can optimize in a easy way, and sometimes we left out all those things, and we wonder why our infrastructure is not become better with time. And this with this monitoring and all, definitely it can help us detect those bottlenecks, and we can work on it and then optimize it at the end. So how to monitor, right? So there are a lot of good monitoring tools that you can use. There are some open source ones and there are some paid ones as well. You can use any of them. They all have they all support very good visualization on data. So at then we want to have a good APM tool, maybe Prometheus, which is an open source tool, and New Relic, which we use at Goldcast to monitor our whole infrastructure. Likewise, create proper monitoring dashboard. So the idea behind creating a monitoring dashboard is if for example, if something happens, we should just look at the dashboard and we can say, okay, that this thing is down, this service is down, and this service is looking up, or the database is looking up, and we can take a quick action to turn those conditions, right? The third would be set up a cron based health checkup for various services. It is always helpful, it is super helpful. It just knows that if something goes down, you just get a ping. Okay, yeah, this thing is down. Let's quickly work on getting this up as soon as possible. Likewise, setting up alerts on important key matrices like abdex score, error rates. If the abdex if the abdex score goes down below this point, then we should get an alert. If the error rate goes above this specific percentage, then we also get an alert, which is super helpful, right? So yeah, let's talk about securing. In order to in order to serve our users better, we need to have monitoring. We need to secure infrastructure as well, right? So I will be talking a bit about the securing and infrastructure as well. So yeah, we know a bit about it as well. Follow the standard practices. For example, if you're writing SQL query, don't just use the value that you're getting from the parameters and just run that query immediately. Rather, prepare that query in order to prevent yourself from from the known exploits, be it like SQL injection, be it LFI, be it cross-site scripting, and all those things, right? And coming to that point, you should definitely should set up a web. So the thing is that the zero day hacks are something that no one can protect you from, but you should definitely protect yourself from the known vulnerabilities, from the known exploits. And obviously the common ones are something that everyone tries on their own. Like if you talk about cross-site scripting, if you talk about SQL injection, if you talk about LFI attacks, these are three the most common exploits that anyone would try. And sometimes what people do is they are just learning those things and they just want to try those things on your server. And that's why you should definitely set up your WAF. WAF is application firewall that you will definitely get with most of the cloud providers, be it GCP, be it Azure, or be it AWS. They all have their own WAF, which they give as a service for their cloud customers. And yeah, you can also you can set up those rules and all. We should set up rate limiting whenever needed. Sometimes people just try to exploit the APIs, and they just want to automate things on their own. Sometimes they feel like, okay, I don't want to do these things manually, so I will just make a script and it will do on its own. And sometimes they just exploit it with that as well. Sometimes intentionally, sometimes not intentionally, but it basically chokes up the infrastructure, right? So we should have the rate limiting whenever we want, whenever we feel we should have that, and it is always grateful. The fourth thing will be rotate credentials and secret. So database credentials and any important credentials, something that we should not have a fixed value. We should not make it a constant thing, right? Rather, for example, if we we can what we can do is quickly is we can just store those credentials on some secrets manager. For example, AWS provide secrets manager we can put over there, and we can create a lambda to basically rotate those secrets. And in every 7 days your password will be rotated, but your infrastructure won't be affected at all. You'll be just pulling your credentials from the secrets managers and all, so it won't affect, and you are secure, right? Boom. So that's what something that we can definitely do. And setting up proper policies for accessing resource, not only in terms of infrastructure level or an application level, but more like infrastructure level, right? Like for example, you have AWS resources, so make proper put proper firewall, put proper security group rules. What are the ports that should be open? What are the ports that should not be open? And often, these things are something that we do manually, and sometimes which becomes an issue, which we'll take care in the next segment of the presentation on about when we will be talking about infrastructure as a code. So yeah, putting up a proper policy and accessing resources for accessing resources is definitely helpful, because you cannot give full access of your infrastructure to some interns, and unintentionally they might leak and leak your infrastructure details, and then yeah, the infrastructure will be down for some time, right? So that is something that we don't want to do. So yeah, for example, if you want to set up web in AWS, we can set up web in very easily. By default in AWS, AWS supports four types of distribution with AWS AppSync, API gateways, load balancer, and CloudFront. We can put web in front of those services, and what will happen is the request will come through web first, and then they will be passed by the web, and then the policies that we have defined on ref, the policies can be of two types, right? It can be either a limiting one, or it can be normal policy, like we just want to check for specific segments, and or we want to detect some slow injection, we want to detect some LFI things, and we want to protect our infrastructure from those things. So and setting up webs is often helpful more, because those requests will be blocked in by the web itself. So you won't be getting some users traffic for which you should care. So yeah, that is a cherry on top of the cake, right? So that is something that we can quickly do with WAF in AWS, and I think this is the similar process for setting up WAF on Azure and GCP as well. It is quick. It is it is super quick. So we can just set it up on the go. And now let's talk about IAC, infrastructure as a code. So, what is infrastructure as a code, right? So, for example, now whenever whenever we are coding, we are let's say we are we are creating a backend. What we do, we create some change, we create a PR, and then PR is that PR is often reviewed by some senior or some manager level person, and when they approve that PR, then only those things get merged in the production, and that's how we change things, right? So similar thing we want to do with the infrastructure as well. So rather than going to the AWS console and checking for creating firewall rules in security groups on somewhere, creating a VPC on different place, creating EC2 instance on a different place, creating beanstalk environment on different place, and then coupling them up all together and all those things is often a cumbersome task, which can be reduced with with infrastructure as a code. So we can just write all those things as a code, and yeah, we have those advanced tools which can transform that code into an infrastructure, and that is all about the infrastructure as a code, right? So yeah, let's talk about the drawbacks if you are manually setting up the infrastructure. So the challenges in maintaining these servers and consistencies between configuration between all the servers and networking is often the most common one. For example, you want to have a staging environment and you want to have a production environment. So what you want to do is you just want to have you just want to have a clone of the production environment, but with a different configuration, right? So often then you will have to do those things manually via the GUI. It is not like that it cannot be done via the GUI, or it is that painful. But yeah, to have to see those things in terms in form of a code is often helpful in assessing things, right? That okay, this thing is something. These are the credentials that we should switch between the different environments and all those things. So which is super helpful always. And the second thing challenging in ensuring the availability of servers with no downtime. So what we can do is we can just push that code, and with the CI/CD we can again we can set up a CI/CD pipeline for this infrastructure as a code thing as well, via whichever tool we want to do it, and basically they will up the service in a go, so we don't need to quickly go on the AWS console and figure out what okay if for example if I want to clone a environment to a different region and stuff like that, right? I don't know to do, and I can just replicate the whole code in IAC, and I can spin up a server in the go. So that is often helpful in with IAC. So let's talk about the benefits. it is always fast and easy to maintain those servers. You can see all the changes in front of you in terms of code, and you can you can configure every aspect of it. The second thing will be consistency in configuration of all the servers, easy maintenance, and reduce the risk. And the fourth thing that I want to talk about is reducing the cost, right? So often, when we are playing with things on from GUI, we often tend to create something, and then we what happens sometimes they are just there hanging and doing nothing. So, and at the same time, we can also we can also with the code, we can also define a specific thing that we want and the other things that we don't want. And with the knowledge from our from our monitoring and all those things, we can know, okay, that these things are something that will that is a that is a redundant thing that we don't want, right? And we can just remove those resources, and or maybe we can have a smaller configuration, smaller capability server in place of that and stuff like that. So yeah, we can do those things easily with IAC. Again, you can do those things with the GUI as well, but with IAC it is just quicker. You just know that I just need to change the I just need to change the instance, right? And it will do the change, right? And likewise, faster in development, software deployments and automated repeated tasks, that is something that is often helpful with infrastructure as a code, right? So why I talked about these three things is monitoring and securing and IC is something that going forward, we all need to implement those things. We should have those things in our infrastructure, in our practices, so that we can deliver in a better way, and we can take use of CI/CD thing in a much standard way, right? And likewise, if we are looking for tools with which we can implement ISC, so Terraform is something that is that works with most of the providers, be it AWS, be it GCP or Azure. Likewise, formation is one default by the AWS. So if you are working with AWS and if you plan to stick with AWS, you can use CloudFormation. It will just work with the Go. Likewise, we have some old tools as well, like Chef and Puppet, and other things. Other such tools are always there. So yeah, it is something that these are the some of the industry leading tools that you can use for infrastructure as a code. So yeah, I will open up for the questions if we have any such.
Fantastic. Thank you, Kuldeep. I think that was a really nice rundown on a number of topics that you covered pretty quickly. So I'm sure people are still digesting that information. I noticed you had CloudFormation, but not CDK. Is that a specific leave out from your perspective,
No,
or?
no. Uh, No, I just wanted to put the known ones which people use mostly. So
Sure.
most of the as we know that AWS is the leading one. So
Yeah.
CloudFormation has to be there, and Terraform is something that works with most of the cloud providers. So that's why.
Cool.
And Chef and Puppet is something that most of the people who have been working for over a decade has been using. So that's why.
Yeah.
Nothing specifically.
Amazing. No, that's great. What do you have a preferred tool of choice? Like if you go into a new team, or if if someone says, "Hey, Kuldeep, what should I use? I'm just starting out."
Okay. Yeah. Yeah.
What would you
Terraform is
recommend?
one thing that I would definitely say, because when we are using a cloud provider, we want to stick with it for the rest of our life. But
Mhm.
sometimes, for some reason, if we want to migrate with it, then for example, let's say if we are using AWS, right, and let's say sometime if you want to migrate to GCP or Azure with Terraform, it will be very easier. But if I stick with the cloud formation, then I will have to stick with AWS forever. So
Yeah.
that's why Terraform will be my preference. But yeah, depends on your preference and also.
Amazing. Well, you've got a compliment in the public chat, which is great, informative session, and I heartily agree. So, Kuldeep, thank you very much.
Thank you so much.
I think that was wonderful, and yeah, that's pretty much it for this frame. I will see you in the backstage soon, I'm sure.
Sure, sure.
Thanks,
Thank you.
Kuldeep.
Thanks so much.
All
Okay.
right.